we have made an instrument that looks at the waveform that comes out of a gravitational wave source. It's interacted with our apparatus, and we have a bad word, a word that I wish we had a better word. The word we call it is a direct detection of gravitational waves. And I know that could be controversial, but it describes what we're doing. We're seeing the actual excitation of our detector by the actual strains that are being propagated in those gravitational waves. And that was not done in the initial observation of gravitational waves by Hulse and Taylor. So we, in a way, have opened a field. We've opened a field of astronomy because we've made a device that lets us look at what's written in the gravitational waves. Now, there's a very interesting thing that comes of that. Many people have said this, but let me say it a little more dramatically. We're listening to the universe. Not that the sound is sound waves, but it turns out all the phenomena we're sensitive to are phenomena that are audible to us. And for example, if you go to a control room or just at one of the sites, put earphones on and listen to, well, if you could, we had to have some sources and you listen to them, you'll find out they're right in where the piano is. You go from, let's say, the bottom of the piano to the top end of the piano, and many of these sources just fill that region of frequency space. So we call it listening to the universe. And it's actually a very poetic and very pretty way of talking about it. It's also confusing. We're not looking at sound waves, okay? So that's the future for us, is that there are many sources out there, maybe even some sources we haven't even ever thought about, that are radiating gravitational waves. And in fact, there was huge discussions in the early days of whether black hole pairs existed. So we've settled an issue by doing the discovery we've made. But let's go on to other things. Yeah. I would love to see Einstein's face if he could read this article that we just put out. I mean, he would have been as dumbfounded as we are, because it's a wonderful proof that all of this incredible stuff, that strong field gravity, is in his equations. Just imagine that. To me, that's a miracle. That, a thing which he couldn't have imagined, and he probably resisted, through much of his life, the idea that black holes even are a solution to them. I'm sure he did, and in fact there are books that say that. But here is now a real effect that shows the very complicated nonlinear dynamics that's taking place in strong field gravity. And I think that is an amazing discovery.